Whenever you have a polynomial divided by a polynomial and the degree of the polynomial in the top is bigger than or equal to the degree of the polynomial in the bottom, you should do some long division. Before I get into that, some of you sitting at home are probably wondering, what the heck is a polynomial? Polynomial is just something like x to the third, because it's a nice whole power, plus 2x squared, again because it's a nice whole power, minus 3x, again because 3x to the 1 is a nice whole power, plus say 7. And that's a polynomial. I couldn't have a term like square root of x or 1 over x in here because this is not a nice whole power, right? You can call this x to the 1/2, that's a fractional power. And this wouldn't count because even though it is a whole number, it's not a positive number, and that's important. So polynomials have nice positive powers on their powers of x, and they're nice whole numbers, no fractions involved. Okay, so with that in mind, let's do some long division. Now you might have also forgotten how to do long division, so I'm going to show that to you. The guy in the numerator goes in the house. At least that's what I learned way back in Algebra 1. The guy in the numerator goes in the house, and the divisor, this x squared plus 1, goes out in front. Now, we ask ourselves, how many times does x squared go into 5x squared? To answer that question, just take 5x squared and divide this by x squared. What would happen if I did this division? The x squareds would cancel, leaving me with just 5. So 5 goes up here. We then say 5 times this divisor. 5 times x squared is 5x squared. 5 times 1 is 5, so I'm going to put that here. And then I have a subtraction going on. That's the next step, is that you subtract whatever you get when you do this multiplication. 5x squared minus 5x squared cancels, as it should. And then I have negative 2x. And the 5 minus 5 cancels as well. So I'm just left with negative 2x. At this point, we can't do any more long division because x squared does not go into negative 2x. So this is our remainder. The long division, after performing this long division, we get integral of 5 minus 2x over x squared plus 1. This 2x, that negative 2x, was our remainder, so it has to stay in that, or that x squared plus 1 has to stay in the denominator. All right, now let's integrate. Integral of 5 should be pretty easy. The integral of 5 is just 5x. The integral of negative 2x over x squared plus 1, I'm going to write an integral that you should just memorize because it's going to come up often enough that there's no point in doing a use of for this every single time you see it. It's just worth memorizing the integral of x over x squared plus 1. This integral is 1/2 ln of x squared plus 1, and I can replace this for this guy, the integral of 2x over x squared plus 1. Of course, because there's a 2 here, I'm going to double this result, and multiplying it by 2 cancels that 1/2. So I'll end up with minus ln of x squared plus 1 plus c, and that is my final answer.